Hello and welcome to Curtidas Math. So this is the first video in a series of videos all aimed at preparing you for science option in secondary 4. So if you're watching this, your secondary 3 teacher probably told you about this video series, gave you a package full of questions to help prepare you for next year, and now you're watching this to kind of help you through that package. So the first thing that we're going to be covering in this series is factoring, and that's what the first package covers. It's a bunch of questions all to do with factoring. So the first topic within factoring is greatest common factor. This is something that you've already learned in secondary 3, but we're going to be looking at some more complicated questions and also just throw a whole bunch of practice at you so that it becomes pretty quick for you to factor a polynomial, because that is something that you will be expected to do pretty quickly going into secondary 4. So you want to be really, really quick with your factoring, especially your greatest common factoring. Okay, so we'll look at a few examples before we do some questions that come out of the package. So here, greatest common factor are steps. The first step would be to find the greatest common factor. So our greatest common factor in a polynomial question will always have, well, generally, will have a number component, so the coefficient, and it will have a variable. So if we're looking at this example, we see that all of these terms, they all have coefficients, and then they all have variables here. So our first step is to find the GCF, the number portion. That's going to be the largest number, the greatest common, the largest number that divides all terms. So it's the greatest common factor between our three numbers. And then the variable portion of the GCF is the highest degree variable that is common to all terms. So this wording can be a little bit tricky, but we'll take a look at it in the example. Okay, so first step, find the GCF. Second step, divide your polynomial by the GCF. So then we do a division, standard polynomial division. And step 3 is to write the final answer as a multiplication between your GCF and your answer of your division. So it should look something like, so your GCF would be here, and then your polynomial, what you have left over from your division, would be in here. Okay, so now getting into that first question. So we're doing our first step. We want to find the GCF. We're going to start with the number. So it would be a good idea to review your rules of divisibility, since that will make it a lot easier for you to identify factors very quickly. Just looking at this question, something that should kind of be like jumping out of the page, screaming at you when you look at this, is all of these zeros. Right? So this tells us that each of these numbers can be divided by 10. That should be very, very obvious. And once we do that and we divide all of these numbers by 10, you'll see that we have 7 left over, 4 left over, and 12 left over. So then we can, just by looking at it, think about, well, between 7, 4, and 12, what would the greatest common factor be for these numbers? And since 7 is prime, the greatest common factor here would be 1. So this makes it really kind of a quick and easy way when you have everything that ends in zeros, is to just look at it without zeros, and then you can figure out what your greatest common factor is from there. So for this, our greatest common factor is just 10. Since we can't divide it, once we divide all of these numbers by 10, we can't divide them any further by a number that's common. So we stop at 10. Okay, so now I'm going to put in my fraction line. I'll put in my 10. That's my greatest common factor for the coefficient portion. Now I need to look at the variables. So here we have x, x, x. So there's definitely going to be an x component that's common. And when we look at the y's, well, there's a y here, there's a y here, and there's no y here. So right away we know that there will be no y in our greatest common factor. And now in figuring out, well, the common x, what are we going to put down here for the x one? This is where you'll notice that the wording is a little weird. It's not weird once it kind of starts to make sense, but it is misleading for some people. So because we're looking for the highest degree variable that is common to all terms, right away, some people might say, okay, highest degree, so that means I take the 3, I put the x3 here, and that would be my answer. So x to the 3 is definitely the highest degree x, but it's not the highest degree x that is common to all, because common means that they all have an x to the 3. They don't all have an x to the 3. So this is x times x times x. Here we have x squared, so x times x, and here we have just 1x. So what we have in common is just 1. So over here is just x to the 1. I'll actually write it in purple. So that's what they mean by that is common to all terms. So it's the biggest degree of x that you can divide each of these by, each term. Okay, so now I guess we can erase this. Let's get rid of these highlightings. Okay, so now we have our setup. So we found our greatest common factor, and now we can do the division. So for this, it's nice to do your little setup. So prepare your brackets with your greatest common factor that you found out at the front. Now you do your divisions, and it's all going to go in here. So 70 divided by 10, 7. X cubed divided by x squared. And we continue. 40 divided by 10, x squared divided by x, 120, and x divided by x. So that's something I want to talk about, is this right here. X divided by x is 1, just a little reminder. So this is essentially 12 times 1 times y. 12 times 1 is still 12, which is why you kind of write it as nothing. You just don't write anything. Okay, so now we'll do the next example. Over here, I'll use blue this time. Okay, so now looking at our coefficients, we have 3, 7, and our coefficient of 1 that we know is there, but that we don't write. So prime number, prime number, prime number. There's nothing that we can divide all of these numbers by. So you can put 1, you can write nothing, doesn't matter. Okay, and now for the x's, x to the 3, x to the 2, x to the 1. The highest degree that is common to all of them, so how many x's do they have in common, is just 1x in common. Okay, so 1x, and now we do our division. So I'm going to put my x at the front, I open my bracket, 3 is not going to change, x cubed divided by x squared, plus 7, x squared divided by x is x. And now this part. This is where some students would just write nothing. They'd put a 0 in there. That's incorrect because of this over here. X over x is 1, the same way 2 over 2 is 1, or 3 over 3 is 1. So right now we have negative 1x over positive 1x. that is going to leave us with a result of -1. Okay, so this right over here. So these are our answers. And now your sheet. So this is what your package should look like. And we'll do, let's look for one that looks kind of complicated. Let's do this one over here, number 9. So this is another situation with the tens, where we have ends in 0, ends in 0, ends in 0. So we can take away, we know that we can divide by 10 right away. And then once we do divide by 10, we would have 8, 2, and 7 left over. And again, looking at these, 7 is prime, so you wouldn't be able to divide any further. That tells us that 10 is our greatest common factor for the coefficients. And now looking at the variables, m squared, m squared, m squared, they all have an m squared. So we can take m squared out. And then looking at the n's, n to the 5, n to the 3, n to the 1. They only have one n in common. And now do our divisions. And this is how it should be when you get good at this. You shouldn't need to draw the division line every time you do this. You should just be able to look at it and figure it out. So something that I do want to mention about factoring is that all you're really doing is manipulating the expression. So now it looks like a multiplication. You're not actually doing anything to it. You're not performing an operation. All you've done is change the format, but this expression and this expression mean the same thing. And are there any others that are interesting? Wonder if there's any that are all negatives. Ooh, there we go. This one right over here. Beautiful question. Okay, so here we can take out a 3. What color do I want to do? Let's use this one, is pretty. So here we have 3, 30, 15. We have a common factor of 3, but not only 3, negative, negative, and negative. They all have a negative in common, which means that I can factor out a -3 from each of these terms. And now looking at the variables, we have v to the 4, v to the 3, and v to the 1. So the highest one that's common to all of them, they all have, is just 1v. And now we do our divisions. So this should be plus 10. -30 divided by -3, it's positive 10. V squared, and positive 5. Okay, so that's this one. If you had left it the other way, and you had just left it as 3v, and this was -v cubed, -10v squared, -5. This is still correct. There's nothing wrong with this. It's just not as nice to look at. Negatives cause not problems, but sometimes people make mistakes when there's a lot of negatives. So if you can take the negatives out so that you kind of isolate them to one spot or one corner of the expression, that would be better. There are times where it's convenient to leave it like this. There's times where it's convenient to leave it like this. it's just more so that you know that you can do this, I think is the important thing here. Okay, and I think that about wraps it up for greatest common factor, or actually we'll do one more that has 4 terms. I think that might be helpful. Do we have any that have multi here? We'll do this one right over here. Okay, so starting off, we need to look for the number. So now I'm just going to check. Yeah, okay. So we notice that they're all even and that the lowest one is 8. So it's always a good idea to check if you can divide each of these by the lowest number here. So we can definitely divide 48 by 8. You can divide 32 by 8. And you also can divide 72 by 8. So that solves our coefficient for our GCF. And now looking at the variable, these two over here in the middle, they only have y's. So we know that x will not be part of our GCF. And now looking at the y's, we have y to the 5, y to the 5, y to the 6, y to the 6. So the number of y's that they have in common is they all have 5 y's. So I'm going to put a y to the 5 over here. And since the x's are not common throughout, we're not putting any x's here. This is what we're dividing by. Okay, and now that first term, the 8's cancel, the y's cancel, we're left with x squared, negative 48 divided by 8, we're left with negative 6, y to the 5 divided by y to the 5, they both go away, 32 divided by 8, 4, y to the 6 divided by y to the 5, just y, negative 72 divided by 8, negative 9, y to the 6 divided by y to the 5, just y, and then don't forget the x cubed. That just gets carried down since there was no x's that were dividing it. So this is how it would get written. And that's it. So I hope that this was helpful. If you have any questions, feel free to leave them in the comments, or you can always go and ask your teacher or come to the math office and ask any of the teachers that are there. We'd all be happy to help. All right, see you in the next one.